Hello everybody, this is Bailey, and today I'm going to be doing a test of my game engine just to show you what it's capable of. So I've created a Java library game engine which integrates with OpenGL and a whole bunch of other libraries, and everything can be controlled through scripting. So in today's episode, we are going to be creating a flat plane and we're going to put a robot model on it. And all of these assets and models have been got from sort of free libraries. I got my textures from textures.com and I got my model from opengameart.com. So to jump into it, I have a scripting file here, which is set as the main script in this file. So the main script has been set to YouTube test.js, which is right here, and we are going to do all of our game code in here. There are three functions. There's initialize, tick, and render. And this is JavaScript, so you can define your own functions here. Like if you wanted, say, a function to do something to your entity, you would create it here. Function do something, something. You could make new functions. It works. It's JavaScript. We're just going to use the built-in functions today, though. So if we run the project currently, it does nothing. You see a blue screen because that is what the game does by default. There's just a blue screen, and we're going to start by adding things to the world. So the very first thing we're going to do is we're going to have a for loop. And for var I equals 0, I is less than 16. This is just an arbitrary value of 16, I plus plus. So we're going to have a two-dimensional for loop because this is creating our floor. And our floor is going to be made up of a bunch of different quads. 16 times 16 different quads to be exact. And how we are going to actually add quads to the world is we're going to reference entity manager dot add entity, like so. And then we're going to pass it an entity reference here. So we're going to say new entity model. And these words have been put into the scripting engine through Java, and they reference actual Java classes. So if I come over to the source files over here, I'm creating a new entity model. And if I go into the entity model class, we can see that models take a model ID, a material ID, a position, rotation X, Y, Z, and a scale. So what we're going to do is we're going to give it those parameters. And we can reference the model that we want to give it by calling model loader dot, and then we could load a model from, say, the model files I have up here. So you see I have a models folder, and in order to put any of these models in, I would just type the name minus the .obj. So say that I wanted to load the chest, I could say model loader dot load model, and I could say chest, and that would load the chest model, but we do not want it to actually load a model right now. It's going to generate a quad for us. So we are going to say model loader dot generate quad, and we are going to pass it a size of 1, 1. So this will now generate a quad, which is of unit size 1, 1. And then the material we want to give it, all the materials are defined in the engine source for now, but you can also integrate and add them. They're just some built-in ones. So if we go down to material manager down here, we can see materials that are in the game. And there are a few that are commented in right now. So we have grass, this is a building. We have white and we have cobblestone. White is just plain white, and that's what we are going to start with. So if we come into here, we're going to say white, because that's the texture we're going to use. And then we need a rotation, 0, 0, 0, and a scale of 1. So if we run this, you should be able to see it in the world, I think. No, you can't see it in the world, and it's crashed. So what is the error? Cannot create a new object with this, with the past arguments. Okay, so this says that we passed it the wrong arguments. We can check that. Oh, yeah, we did. We didn't give it a position. So we're going to give it a new vector 3f, and this is its position in the world, and it's going to exist at I for the x, 0 for the y, and j for the z. y is up in this engine. So if we run this, now we have the right number of parameters and it doesn't crash. But we can't see anything, and that's because we don't have a camera. There is a default camera, but it's just not pointing at this position of the world. So in order to set the camera, we are going to say camera manager dot set cam, and I'm going to write IntelliSense for all this later, but we're just going to pass it a new FPS camera. If we run this, we can now see that it has crashed. Oh no, it crashed pretty badly too. That's probably because we spent something wrong. Camera manager.setCam is not a function. So if we go to the camera manager source file, which is right here, we can see that we need to call set camera, not set cam. So I have the sort of stack trace integrated with my scripting engine. So if you do something like this, where you've typed in the wrong function, it will catch that and it will tell you where the problem is. So now that we call set camera, you can see that everything's working. And we have a whole bunch of quads here, 16 by 16 quads to be exact, but they are not rotated in the right direction. So we're going to fix that next. So you see we have our rotation X, Y, and Z parameters here. If we change this one, which is the X rotation, to 90 degrees, all of the quads will rotate over the X axis, which is going that way and that way, to be flat. So now all of the quads go over themselves, rotate over themselves and line up to make one cohesive quad. But you'll notice that we just have a blue background and these black quads. There's no lighting. So we're going to add a light next. And the way that we do that is by calling the lighting engine. So we say lighting engine dot add light, and then we give it two vectors, a position and a color. So we're going to say new vector 3f, and we're going to give it a position of 0, 0, 0, and we're going to give it a color of 1, 1, 1. And this is the R value, the G value, and the B value. So this will be a white light, and it will exist at 0, 0, 0. So if we run that, you can see that there is now a light at this position. Let's make it a dynamic light though. So this is a set position. However, we can give it a pointer to the camera's position by just giving it a pointer reference. And the way we do that is by calling, or we're going to set the light's position to be the position of the camera, just so you can see it moving around as I move around. And the way we do that is by calling camera manager dot get cam, that will return the current camera, dot get position. And now if we run this, you can see that the light's position changes as I move around. So if I move up, move down, this will follow. Nice. So now we are going to add a model to the world here. And the model that we're going to add is going to be a robot model. So we can add that robot model to the world pretty similarly. Let's go down here, and instead of calling modelLoader.generateQuad, we are now going to call modelLoader.load model, I believe it is. We can check that by going to the model loader source file, which is down here. Yes, model loader. And we have generate quad as a function, generate quad 45, generate train, generate cube. I think it might be the, where is it? Generate cube, generate train. Oh, there we go. This is the first one. It is just called load model. So if we come here, say load model, we are going to pass it the name of the file we want to load. In the package folder next to the source, we have a folder called models, and this contains all of our objects that we know about. So you can see I have a robot file, robot.object. And if I put that as the file we're going to load, you don't need to add the .obj, it'll just know that it should use .obj. We're not going to put it at ij, we're going to put it at 8, 8, and we are not going to rotate it at all. We are just going to use the white texture for now, just to check that it's loaded okay. So, you can see that we have this robot model, which is loaded. It is in the floor, so we're going to move it up. And it is using the white texture, and it has lighting working on it. Sweet. So, let's move it upwards, say 2 units, and let's give it a texture. Let's use cobblestone, just because that's a texture that I have. And just for fun, let's add a new light at this position. So instead of referencing that, I'm going to reference that. And let's make this a red light. So that's full red, no green, no blue. And let's also rotate this around the y-axis 180 degrees. So it's now facing the camera when you start. There we go. So now you can see we have a red light on this model. Model's facing the camera, and it has a texture to it. The texture is also bump mapped correctly. That's just part of the engine. Sweet. So this is just a little test, just to kind of prove that we can modify entities dynamically. I can show you that we can actually rotate and change properties of this entity in real time. So to do that, rather than generating and adding it in one call, so to speak, we are going to create a variable called robot. We're going to put it up there, and then in here we're going to instantiate it by saying robot equals this call here. So now we have this robot object, and we can add that robot to the world. And in tick we can say robot.rotate. And this takes floats for XYZ, and we're going to have it rotate around the y-axis very slowly. So 0, 0.1, 0. So now it'll rotate around the y-axis. See, it's rotating pretty slowly. We can change that. But yeah, that's it working. So say that you have just finished your game and you have all your source code and you want to release it. So what you can do is you can come into the launch.json file, and you can either set a preset size with width and height, or you can just set full screen to true, which is what I'm going to do right now. And with that, if you launch it, you can see that we have the game here. And this is it running in full screen. The only reason it's so choppy right now is because I'm recording in 4K. For you guys who aren't recording, this probably runs a bit faster. But yeah, you could then release your finished game, and this is what we've made today. So stick around for some future tutorials. I'm going to be tweaking the game engine, and ultimately I'm going to release it. You guys can make your own games in it and play the one that I'm developing. The game I'm developing is called Murder Train, and yeah, I guess you guys should just be ready for that. So yeah, just keep an eye on future videos, and hope you enjoyed watching this one. Thanks.